Pac-Man symbols. Let's review really quick what the Pac-Man symbols mean. I'm about to turn, let's see, I'm going to be 43 in April. Wasn't it somebody's birthday not too long ago in here? Whose birthday was it not too long ago in here? Castro, was it your birthday? Naheda, that's right. You're 17 or 18 now? Okay, you're 17. So let's see, Naheda. On your notes, going to put, you mind if I use you as an example, you and me? Okay. Put let n, going to write let n equal Naheda's age. Do that for me. So we're just using a real life example right now. You've drawn this function of some parts are increasing, some parts are decreasing, some parts are increasing. Now, before I show you how to describe what's increasing versus decreasing, I got to describe how to write inequalities. For instance, let n equal Miss Naheda's age. Let m equal Mungia's age. So Naheda versus Mungia. Who's older between me and Naheda? Why did you say that so fast? Just kidding. So here's what we're going to do. M is greater than n. Let's not confuse what these symbols mean anymore since you've been a little kid. So go ahead and write Mungia's age is greater than Naheda's age. The Pac-Man wants to eat whatever's bigger. Think of like a little Pac-Man mouth. Mungia is greater than Naheda in terms of age. Now let's see if you guys remember your junior high days. What's an equally valid way of stating what I just stated in a different way? How can I communicate this truth right here, that Mungia is greater than Naheda, in a different way, but it means the same? But I wouldn't be equal to her, huh? There you go. But Naheda, look at this, is less than Mungia's age. This and this mean the same thing and just said in different ways. Naheda's age is less than Mungia. See, the Pac-Man, the mouth, pretend it's like a Pac-Man mouth. The Pac-Man wants to eat whatever's bigger. So whatever the Pac-Man is facing in terms of his mouth being open, that's the bigger, the greater portion, so to speak. Okay, so far so good. Naheda is less than Mungia. Mungia is greater than Naheda. They're saying the same thing in a different way. Now, back up here. Back to our graph. That's a little review of greater than, less than. Up here. On the little crappy picture that you drew on your own notes, because I don't care if it's crappy, but it's probably crappy because you did it really quick. On your x-axis, go to make a, put a -1 here. We already know that's 0, a 1, and then a 2. Go and just add the numbers for me right now on your x-axis. Okay. Here we go. So this function is increasing from left to right. It's increasing when it's going up from left to right. So right here it's increasing. Oops. So from here all the way up, it's increasing from here all the way to right there at the peak of that little hill. It's increasing from here to here, and it starts decreasing coming down to the bottom of this valley. So you look, it's decreasing from here to here, but then it starts increasing as we come up out of that valley. So you got peaks, we got valleys, increasing, decreasing, increasing. Now, mathematicians will describe the increase and decrease in terms of what values of x is it increasing and what values of x is it decreasing. So right now, this function is increasing for what values of x? Let's see. So all these points right here, get all these points where it's increasing. What values of x do these have to be? So I'm just focusing on the x coordinates of all these points here. All these points. Where it's increasing, what does x have to be? Well, x has to be less than a certain number. Watch. Let's see if this makes sense to you. Let's see if this makes sense to you. Underneath this graph somewhere on the side, but the function is increasing when x, watch this, when x is, so right here at the top of this mountain, so look at the top of the mountain, it stops increasing. It's increasing up to the top of the mountain. What value of x is this right here? 0. So the function is increasing when x is less than 0. Because look at all these values of x are less than 0. Look at this would be maybe negative 3 point or negative 2.3, negative 2.2, negative 2. Here's negative 2, negative 1.9, negative 1.8, negative 1.7, negative 1, and then 0. All these values of x, while it's increasing, all the values of x, if we were to get all the ordered pairs, they're all going to be less than 0. So the function is increasing when x is less than 0. Once x is 0, look at right here. If x is 0, it's no longer increasing and it's no longer decreasing. It's just right on top of this little hill. But after x is bigger than 0, look at if x is 0.1, 0.2, 0.3, look, it's starting to decrease. It's decreasing, decreasing. As soon as x gets to 4, it stops decreasing and starts increasing again. So the function is increasing when x is less than, boom, 0. And where's another part where it's increasing? Right, after 4, huh? So it starts increasing from this point on, forever. So the function is increasing when x is less than 0, boom, and when x is greater than 4. Look at this. It's like little x windows, like windows of increase or windows of decrease. When does it start increasing? When does it stop increasing? How about decreasing? When is this function decreasing? So it's increasing when x is less than 0. Look at all these values. All these values up to right there, x is going to be less than 0. And it's going to be increasing for all these values when x is bigger than 4. So bigger than 4 increasing, less than 0 increasing. How would I describe the decreasing? This little window right here. Let me highlight the window in black here. How would I describe this here? This part of the function where it's just decreasing. There's only one little sliver, this little window right here. It's decreasing. The black part. the function is decreasing, write this with me, when, how would I describe that? How would I describe x there in that black portion? Right here, this little window here. From here to here, it's decreasing. Right? It's decreasing from here to here. So the function is decreasing when? Somebody. Okay? Right now we're only going to describe x. So look at, from infinity to 0, it's increasing. Boom. From x is greater than 4, it's increasing. Boom. So this is the increasing part. But now, when is it decreasing? From what to what on x? The x-axis only. From 0 to 4. So look at this. When x is 0, if it's greater than 0 and less than 4, that function is decreasing. So watch this. The function is decreasing when x is greater than 0 and less than 4. Look at that. Look at how x is two things at one time. It's got to be greater than 0, because that's when it starts decreasing. It's not decreasing at 0. It starts decreasing after 0. And it stops decreasing at 4. Not when it's 4, but right before 4. So look at this. X has to be bigger than 0 and less than 4 during the decrease. So I'm describing decreases and increases with little windows. The first window is increase. Boom, right here. That's right here. That's the first window of increase when x is less than 0. The second window of increase is right here. That's right there. X has to be bigger than 4. And then the last window of decrease is what Ayala said. X has to be in between 0 and 4, greater than 0, less than 4. The second one you're going to have to graph here. So let me give you a piece of graph paper. Let me pass out a graph paper. We're going to go over one more example. Just one more. Yes, ma'am. Say again? After this. One more example. Yes. Go ahead and copy down the graph that you see. A couple noodles, that's good. Ayala. Keep this graph paper for tomorrow also, so we're going to get into some more examples tomorrow. We're only getting into one more today. Copy down this graph that you see. Of course. You got it. Yes, sir. My bad. Camacho. So the function is increasing from negative infinity. Look at. I want blue, I want red. Come on. Negative infinity all the way to the top of this mountain right here. It stops increasing right there. And it begins to increase after this valley from here all the way to positive infinity. So in red right there, that's where it's increasing, this function. I need to describe that in terms of x. What are the x values for this increase, the increase intervals, these sections of increase? So how about this? Who would like to take a stab at this? What are the x values here of all these points? Of all the infinite amount of points here. So negative infinity to the top of this peak right here. Negative 1, negative 2, negative 3. Negative 3, huh? So x has to be any number less than negative 3. Because all these numbers here, if all these numbers for x this way is going to be less than negative 3. Numbers this way are greater than negative 3. So here's negative 3 right here. So x is less than negative 3. That's all the x values where it's increasing. Look at it, it stopped right here when x is negative 3. Boom. And it starts increasing again. Right over here. It starts increasing at this point for x all the way to positive infinity. So what are the x values there? Negative 1. Is x going to be bigger or less than negative 1? So if you're going that way, the number line is bigger. So x has to be bigger than negative 1. X is greater than negative 1. Not equal to, but greater than negative 1. That's where the function's increasing. So anywhere it's going up is where it's increasing. Anywhere it's going down is decreasing. Now in blue, let's describe the decrease. So here's a decrease right here. Look at that. So between here and here on x, that function is decreasing on x only. Not f of x, just x. Between here and here. So it's decreasing. X is going to be, it's going down after x is greater than negative 3. So x has to be greater than negative 3. Look at this. X is greater than negative 3 and less than negative 1. That's where it's decreasing. A little window there of decrease in blue. So we're focusing on x values only here when we're describing increase and decrease. That's the moral of the story here. What do you guys think? No biggie, right? I'm going to take about a minute to check your social media if you need